Hey guys, welcome to identifying the equation of a line from a word problem number 3. This is an interesting question. We're being asked for the same thing as we were kind of in number 1 and 2. We want the rate of change, which I'll remind you again is the A, and we need the initial value, which I'll remind you again is the B, and we need that from the word problem below, and then of course at the end we have to write the rule for that linear relation, which is a fancy way of saying, hey, you tell me what y is equal to ax plus b is going to look like from this particular word problem for this particular line. Now, in the first problem, we had 2 points that were given to us on a graph. And in the second problem, they kind of told us the slope and they told us an initial value. This is a slightly different version. It's actually a little bit more like the first one. Let's have a read and I'll show you. Enoch jumps from a plane while skydiving. Good place to jump from when you're skydiving. 120 seconds after jumping, his altitude is 7,640 meters. So he falls for 120 seconds and he's at that height. His altitude is then 750 meters, so he's at this new height over here above the ground after falling for 250 seconds. So the further he falls, obviously, the less altitude he will have, right? So as he drops from the airplane, his altitude is decreasing, and that altitude is decreasing as time progresses, as time is moving on. So what we kind of have to figure out are two things first. We know at some point we need 2 points if we're going to calculate A, and we don't have his initial height. Nowhere here does it say how high that airplane was flying, to begin with. We don't know what that measurement was at the start when he first jumped. We only know these 2 other points somewhere along the way as he was falling. So what that is, or what these are ordered pairs. These are actually coordinates. If you remember in the first problem, you had something like this. You had a graph with a line with a couple of points in it, and we read the x's and y's off those points in order to calculate our A. Well, this time, instead of giving us the points with a graph, like they did in question 1, they've gone ahead and given us the points in words. So if you watch really carefully, you'll notice that this first sentence here says, okay, he's falling for 120 seconds, and his height is 7640 in terms of meters. So at 120 seconds, his height is 7640. Now the question is, which one's an x and which one's a y? Well, you have to think about which one is dependent. Remember that the dependent is always the y. Well, think about it. His height, his altitude, depends upon, this number depends on how far he falls. This one depends. It is the dependent. His altitude depends on how long he's been falling. So that number right there is going to be the y. And the 120 seconds is the x. And a little hint here, time almost always is an x. So the second piece of information, you've got to be careful because the sentence, grammatically, just in terms of the English language, they've reversed the information, but the pattern remains the same. His altitude is 750 after falling for 250 seconds. So when we go to set up our second ordered pair, it's very important you remember to keep them in the same order. X over here, or x1, y1, I want you to remember that x was time, and we know that the altitude is the dependent variable. So which of these 2 numbers is the altitude? They gave it to me first in the sentence. Just because it comes first in the sentence doesn't mean it's first in the ordered pair, right? Remember that the altitude we've decided is the dependent variable, just like it was over here. So this is my y. And the time is still my x, 250. So that I could label as x2 and y2. Now what does this allow me to do? This allows me to calculate my A. Remember that A is equal to y2 minus y1 over x2 minus x1. And so now with some basic calculations, we can calculate the rate of change. Let's see what happens. So 750 minus 7,640 will be the top of the fraction, y2 minus y1 over x2, 250 minus 120. So come over to the calculator and we'll go 750 minus 7,640. And when we do that, we get negative 6,890. And then we'll do the bottom of the fraction, 250 minus 120, and that's going to give me 130. That's an ugly looking number. We'll see how that simplifies when I do the division. Clear that up. 6890. Oops, I have to make it negative first. Negative 6890. And I'm going to divide that by 130. And that's going to give me negative 53. Now, what is that negative 53, and why is it negative? Well, think about the height. Remember, his altitude is shrinking, right? He's getting closer to the ground, so the distance he is from that ground is going to be getting smaller as time goes forward. It makes sense that we have a negative rate of change because we're considering his altitude from the ground. I mean, at some point he's going to hit zero. Hopefully his chute opens first. So we've got our A. There it is, fully rendered. And now we need to figure out our B. So in the equation now to get the B, since we don't know how high that airplane was when he jumped out, we have to find it algebraically. And the way the equation sets up is we start off again with our master equation, y is equal to ax plus b. And keep in mind, we know the a. So if we have an x and a y, we could solve for b. Well, where are those x's and y's going to come from? Well, they could come from here, or they could come from here. You have to choose which of these 2 points, either your P1 or your P2, and plug one of them into that equation over there. So I'm going to use my P1. You'd get the same answer, believe it or not, if you used P2, if you do the algebra properly, but I'm going to use P1 just because as a rule that's the one I like to use. So there's your x, there's your y, and we have an a. X, y, a. So y first. So what's that y? 7640 is equal to a, which we figured out is negative 53. We know the x is 120. And at the end is plus b. So now we have to simplify this equation over here. We're going to do this multiplication first. So negative 53, it's already in my calculator. I'm going to multiply that by 120 and hit equals. And that's going to give me negative 6,360. So I rewrite the equation, but now instead of that product over here, I'm going to write down the actual value of it, which is negative 6,360 plus b. Now I'm trying to isolate my b. So this negative 6,360 is kind of being taken away from my b, so I'm going to add it to both sides. And when I do that, I'm going to get my b. So there's my negative 6360, which I have to now make into a positive, right? Because I'm adding it. So 6360 plus 7640. And that's going to give me 14,000 as the initial value, which means the airplane was 14,000 meters above the ground when Enoch stepped out of it. And the last step always is then to write the rule. So y is equal to his height from the ground, his altitude, will always be equal to negative 53 meters per second plus the 14,000 initial value. And that is how you do a word problem from 2 points when the 2 points are written in instead of given in a graph.